Oh, you didn't do it.
Okay. So if you graph a sine curve,
You're not sure.
okay. Oh, there we go. My bad. If you graph a sine curve, when you initially get on the ride, you're getting on at 0 degrees, right?
Oh, I went down first. Is that bad?
Yeah, you gotta be going up and down. So because you're doing y equals sine x. So this is where you're getting on. So I put a over here. Then when you reach the bottom of the water pit, that'd be at 270 degrees. That'd be over here.
How do you know that?
Because that's the lowest point. And you're halfway between the highest point and the ground level. You can put it in a couple places. You could do it 135 degrees.
Like, how do you know these?
That's because I just know.
But how are we?
Exactly. Here's what you can do. So we get on in the beginning, right? That's 0 degrees. Yeah. Okay. Then the sine curve looks like this. So you hit the peak. Remember when you do that wheel thing, you hit the peak, then you get back down to the middle, and then you go beneath the ground, and then get back up to the ground, right? So for part B, when you reach the bottom of the water pit, that's the lowest point of the curve. What degree does that correspond with? 270, based upon your notes. Or you can graph it. Graph it, right? And you can see that's the lowest point. And then when you're halfway between the highest point and the ground level, highest point's at 90, the ground level is at 180, or from 0 to 90, same thing. You can put C actually at 45 as well. That'd also be a true statement. Exactly, right. If you want to do the highest point, then the ground, then of course do 135. If you're doing the ground, then the highest point, then you do 45. But if I just generally said, oh, halfway between the highest point and the ground, then there you go. Lincoln, go ahead, yes. Sure, no problem. I made extras. No, I like stuff. I anticipate this, but
We're doing so bad.
I will run out.
So shitty.
Oh, how do I do this? Actually,
Mr. I think I might have grabbed an extra.
yes, you know what? Because there was someone who did that. No, actually, I put together one. No, we're good. No, just keep that. Actually, no, don't. You know, another homework packet?
Yeah.
So you have to.
Okay.
All right, so we're good. No, perfect. No, that's why I did all organization, right? Okay, anyway, so we're go 736. That's okay. So John, you understand how we got those?
Yeah.
Okay. Now for 737, it's the same thing, but now you have to write words. So A would be after the high point. After each a high point, that's why I put A. B would be underground. C would be back of the ground. That's how I describe that. Just keep it very brief, 1 or 2 words, maybe 3 words, maybe 4 words. I don't know. But yeah, A, you've clearly reached the peak. Like you're at this, so you're on your descent. Well, it's not a roller coaster, obviously, it's just a Ferris wheel. But you've reached the highest point. So you have like this beautiful vista that you could see from up high, and then you're starting to go down to the ground, so you're getting a little scared. B, you are definitely underground, so it's dark. And then C, you have a huge relief, you're out of this ride. And if I look at the answer key should say something of that sort. It's kind of hard to read, so let me zoom in. You guys have access to this. Yeah, above the ground, just past the highest point, just below the ground, back to the starting point. So, and if you put it on a circle, it'll look like that too. So it's connecting the graph to the circle. That's what 737 does. For 738, okay, this is I overheard people talking about this. What you want to do here is set up a proportion. So if Julie is this tall, her shadow is that long, to draw a triangle, right? So what's my vertical leg? What's my horizontal leg? Okay, now you're going to do another triangle that's similar, but much bigger triangle. Do we know the height of the tree? No. Do I know the shadow? Yes. How do I set this up? Yes,
I got 83.
Yeah, that's correct.
3, but you got like
that's correct.
2.4.
Just maybe punching the calculator wrong. I don't know. So if you do that, actually, maybe CPM's wrong. Let's find out. Okay, the CPM could be wrong. Yeah, I get 82.35. What does CPM say?
83.35.
Yeah, 82.4. That's correct. Yeah. 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 Okay. Okay, for 739, it's kind of I don't want to say a dumb problem, but it kind of is dumb because you guys have technology to do this. This is more to help you understand how logs are broken down. Back in the day, if you didn't have these fancy calculators, you had to actually use these tables to help you out. So, you guys know that, right? That's a true statement. You'd agree 2 times 3 is 6, right? How do I break this down? You guys remember from last unit? Yep. Perfect. And that's 0.301 plus 0.4771.
How are we supposed to do that without a calculator?
How to add those two? I wouldn't ask you to do that. You just, but you, what? What's 0.3 times 0.4? Yeah, and then 0 to plus
I
7.
know, but how do you go from log 2?
Oh, you have to be given that.
Oh,
It's given to
okay.
you. You have to be
Okay,
given that,
okay,
right?
okay.
The point I'm trying to make is that if you didn't have a fancy calculator, but you had a table of values, that's how you would evaluate it. So you 0.778, I think, something like that. So yeah, it should be 0.7781, I think. Yeah, there we go. And you can see how they're all broken down over here. Yeah, this is a perfect answer key. 15 is 3 times 5. 9 can do 3 squared. 50 can do 25 and 2, but 25 can do 5 squared. And move that 2 to the front. That's how you could do that. Again, not anything I'm asking on a test because I think it's just kind of dumb. But yeah, but just to know you could break it down. We are gonna put logs in our test upcoming on the 28th. We want to review logs, make sure you guys don't forget. We're gonna work on a test on Friday. I'll have details about it by Monday next week.
What day is it? That's Friday?
Yeah. Of next week.
Yeah.
Yeah, and I'll try to be available on the Thursday night. Unless the UC San Diego makes a Sweet 16. We'll find out.
Oh, I gotta go losing first round.
All right,
Cool.
we'll see.
You go to UC San Diego?
I'm undergrad, yes. I used to root for Stanford, but now Stanford sucks. So, well, not yeah, I am bandwagon actually. I will admit that. For Stanford sports, I can be. All right, 740. 740, that should be pretty easy. Just plug in 0 for x, y is 1. Not hard. However, the x-intercept, you have to use quad form to do that, or complete the square. You guys okay with that? How to use quad form? Okay, not hard. Again, just old stuff. To write this in vertex form, so if you have the equation, what was it? Y equals 3x squared plus 6x plus 1. Is that correct? Yeah. You guys remember this? You can do that. So you don't have to complete the square. And then the y core of the vertex should be easy. Which should be -2. And you have a 3 out in front. That's why we get that equation. Hopefully that makes sense. I know my handwriting sucks, I apologize. But that makes sense, -b over 2a. You guys remember that? Or you could have completed the square. That's just a little more labor intensive. So I think using the form approach might be a better way. Swear. Like a medical doctor? Why? Oh, I have a lot of friends who are, it's funny you bring that up because for a brief moment, I thought maybe doing pre-med, but then I saw what you had to do. It's like, no way. Plus, I make more money as an engineering major. I did. But I have a lot of friends who are doctors. Actually, a lot of my really close friends are
What did you do
doctors.
for engineering?
Chemical engineering. I worked at Intel for a couple of years after, not in 1999
You
after
not
college.
stay there?
Was that?
Why didn't you like keep?
I got into grad school at Stanford, so and I was up in Oregon after UC San Diego, and I wanted to come back home. And then I got into tutoring. I liked that better. And also there was a 9/11 and a war that was going on, and the economy went downhill. So yeah, kind of did a career switch. So part of my life story. Yeah, let's keep going. For 742.
It was just one page of homework, right?
Yeah, exactly. That one I just do do graphically. You have this, and the other one's gonna look like this, I think. Did they overlap? Did they overlap? I think they did. Yeah, they do. Did you get something like this, guys? Yeah, so they touch in a lot of places. They start touching where at -5, and then everything less than -5. That's kind of a weird. So there's an overlap. Yeah, it's kind of a funny one. So that's so you express the answer not as a single number, but as an inequality. This one I do graphically. Actually, could you do this one? No, that'd be kind of weird to do. Yeah, I don't know how you do that one algebraically. I just did that one graphically. I'll show you the answer for that one. Just graph and Desmos. They don't touch. So there you go. Yeah, actually that is pretty obvious because 2 to the x is this. And I guess log base 2x. Oh yeah, obviously they wouldn't touch. Well, yeah, why would they not touch? How are these related to each other? They're what? They're inverses of each other. Yeah. I mean, inverses could touch, but in this case they don't. And lastly, you have a system of equations. It's just old stuff. So we're gonna start being more intentional about having you guys review old stuff because we don't want to get to May, like end of May, like, oh crap, we did this like 4 months ago. Because remember we did matrices 4 months ago, right? I mean, back in January. So we don't want you guys to get in that situation. Because I mean, and I will admit, our final exam of the spring last year was an absolute train wreck. I don't want to be a train wreck again. But I think part of it was, well, actually, I think most of it's my fault because I didn't do enough quizzes. And also, we didn't do enough review.
But last semester?
Spring of last year
Oh.
was an absolute train wreck.
Really?
Yeah, it was
worse,
bad.
Worse than the beginning of our first semester?
What was that?
Worse than the beginning of our first semester?
Well, first semester wasn't that. I don't know. How's the final? I don't remember.
No, not the final, like the beginning of.
Oh yes. Oh yeah. It was. Oh yeah. It was
Oh,
horrible.
I did hear about this
Wasn't
one
there a
being.
13%?
Oh, was it?
There's a 13% curve for those at the low end, so they wouldn't fail the class.
Oh, for the final?
Yes.
I heard about it was. I heard it was
There were a handful of people crying.
I heard it was awful.
Yes.
Like hard.
You could feel the stress in the library. It was like you walked in, it was a ball of stress. It was just I got stressed out.
Was it you
being
think
there.
You made it too hard or?
No, it just they just weren't they just didn't feel ready for it. But I think that's part of because I don't think I did enough quit. It's a lot of different. It's a lot of material we did.
Also, like, there's so much more this semester.
But we get our own day though. We get our own day for math fun. We do. This semester we do. So I think that's a good thing.
Oh, love that. Yeah.
I don't know. Anyway, you guys good at 44? We good? Any questions? California's that and yeah, Cal, UW, and UPenn. So anyway. All right. Cool. All right. So let's move on to notes. Oh, let me talk about what's going on the quiz today. Really quickly.
Is it at the end of class?
Yeah. So after I finish the notes, we'll do the quiz. I'm doing it right now.
Right.
Yeah. All right. I'm not going to give you these ratios, but you guys should know these.
Wait.
You can use a but you can use a calculator. Calculator's allowed. Calculator's allowed.
Would X be like X root 5?
Well, hold on, whoa. Slow down.
Oh, down.
Okay. So that's a ratio that you can use, or you can use trig. It's totally up to you. If I use the ratios, then this has to be 2 root x over root 2. How would I reduce that? Exactly. It becomes 2 root 3. Because root 6 over root 2 you can combine, right?
Oh.
Right. For example, what if I have root 25 or root 4? Isn't that just 5 halves? But I can also combine it like this also, right? I still get the same thing.
We're not reading that for X on the left one.
Yeah.
Exactly. And the y is gonna be the same thing. Y will be the same thing. I'm gonna get there in a moment. Guys, let's just settle down. Or you can do this. You can do sine of 45 degrees equals x over 2 root 6. And then sine 45 degrees is root 2 over 2. Or use a calculator and multiply it out. But since I am asking for in simplest radical form, you do need the ratio. So how about this? I'll do you guys a solid. I'll put the ratios on the board for today. You will need to know for the test though. But because I do want the answer in simple radical form, so I don't want decimals, so you can't really use a calculator. So let me do it one more time. Actually, go ahead. Try good. All right, so one more time. So this has to equal x root 2. So then x would be 2 root 6 over root 2. And how do you reduce root
Why-
6 over root 2? Because I have to divide, get rid of x. Sorry, to get x by itself. That's why I get 2 root 3, 2 root 3. Now let's do the 36 and 90.
For x, would it just be like x or 8 root 5 over 2 root 3?
Yes, correct. Correct. Yeah, so if you have this here, that's 2x. Oh, come on. Come on. There we go. That's 2x, that's x root 3. That makes sense? Those ratios? I'll give them to you, don't worry. For today. So what does y have to be? It has to be half, right?
8 root
4 root 5. And then what is x gonna be 4 root 5 times root 3? And what happens if you multiply root 5 by root 3? Root 15. They're both prime numbers, so you can combine like that. You don't have to simplify afterwards. What's the acronym we use to help remember trig ratios?
So,
Yeah, that's pretty easy. It's a quiz question. I'm giving you a different version.
yeah, I'm all.
And then how would I do this one?
You just do it like Toa and then you just do it.
Sorry, Nathan. Nathan, so let's back up.
Whatever reverse.
You got it? Okay. Okay, for 4. Yeah, what do I do? That's 18 degrees. Cool. That's easy peasy. What's sine of 72 degrees? That's y over 3. Now you have to use a calculator. You have to give it to as a decimal.
Y root 3 or y over 3? You said root 3.
Y over 3?
Sorry. No.
Sorry, did I say root 3? My bad. So whatever that is. And then how do I get the x? What would I do? Wait, I messed up. Sorry, guys. I'm going too fast. Take a deep breath. I should slow down. What trig function should I use? Not sine.
Which one are you tan?
Tangent. My apologies. I mean, you should solve for that. I didn't label it.
When you say part 2, you're asking for sides or like
You should solve for everything that's missing, but honestly, just the sides are fine. I'm cool with the sides. Whatever's labeled.
2?
Okay, then how do I solve for x? I should use sine, not sine, but
Cos.
yeah, if it was 18, I could use sine. But if I'm gonna use 72, then I better use cosine. Now this was a little tricky. How do I solve for x?
Multiply x sides. So
Right.
X times cos 72 equals 3 and then divide by cos 72.
Right, and then you divide. So 3 over cosine.
Oh, in.
Very, very important though.
How was that? Yep.
This has to be the biggest side. Do not let
I'm
x
the
be
big
less than
bird.
3 or less than y.
I'm the
It
big
has to be the
bird.
biggest side, because helps the biggest angle.
Okay. So if you got something that's off, double check your work. Make sure it physically makes sense. Yeah, John, stop. All right. Okay. Cool. That's quiz. Let's do the notes now. All right. So let's move on
We take the quiz
to.
now and then do the notes after.
No.
The notes aren't related to the quiz.
No, kind of are. No.
I thought you were.
No.
The bad stuff.
All right. All right. So
Where's
let's
the
go.
notes
Your notes packet. This is notes. I don't know.
at? What's the front of it look like?
Is it the one that says class notes? I don't know if you lose them.
Oh, yeah, no, right here.
All right. Page 5. 7.4. Well,
Is
that's
this the unit
Sharpie.
circle or whatever?
Correct.
I don't even know what this is.
I don't either.
Yeah.
All right, here we
Did you
go.
memorize that?
We'll talk about that.
Okay.
Okay.
Yeah.
No, not the whole thing. We're not, but we'll talk about that next week. All right, so we want to find the coordinates of point P. If you think about it, guys, quiet, please. Thank you. I'll call us X. I'll call us Y because X is horizontal, Y is vertical. So what I could do is I could do some trig, right? So for example, I could say cosine of 34 degrees equals what over what? X over
1.
1. So I can solve for X. Or sine of 34 degrees equals y over 1. So you could totally do that.
So cos 34 equals x.
Cos 34 equals x. And what we're gonna discover is that the x coordinate on the unit circle will always be cosine. The y coordinate on the unit circle will always be sine. We're gonna talk about that. So more good. Because it's going to be a nasty decimal. That's why. Because 34 is not it's not one that has like a ratio like 30, 60, 90, 45, 45, 90. So that's why it's an approximation. Yeah, great question. Because we cannot get that precisely. Sine 34 will be 0.559. Now, one thing that is also an important observation I want to make. Actually, I'll do that for 746. I'll do the observation. So for now, we're just using trig. So we're continuing to figure this out. How do I figure it out? I did trig.
Degrees thing.
Or SOHCAHTOA.
But we didn't even solve p. We didn't even...
No, we did. The coordinates are going to be this.
Oh, you're just solving for the coordinates? Oh, okay.
Those are the coordinates.
Oh, never mind.
Why are those the coordinates? Because how far did I run along the horizontal axis?
Are we ever gonna 0.8?
And how far did I run up?
0.5? Are
That's
we ever gonna
why-
have to solve for like p to like this like
The height? We did. That's why.
no like that.
Oh, the arc. No, don't worry about that.
Okay.
They did that last year in geometry. No, that's
so
not necessary for this class. No. It's not hard. Just do circumference and multiply by the central angle. Hold on. Whoa.
It's pretty easy.
That's a fraction of 360, right? Of course. How long? Yeah, full circle 360, right? And then how long says circle circumference, right? Yeah, so if you take this angle, if you take that fraction with 360, multiply to the circumference, that gets the arc. You might need it for the SAT or ACT. I don't know.
Have you taken it yet? Okay, good. You didn't need him? Okay, maybe not. All right. Now, how do we generalize this? Here's how we're going to generalize it. We're going to generalize in this manner. I'll call this X and call this Y.
Like sine theta
Well,
equals,
there's a few ways we could generalize it. First off,
equals x over 1.
what famous theorem am I writing here?
By that.
Which is what?
H squared plus b squared equals e squared.
So my A and B could be X and Y. And those could be interchangeable. And my C is what?
1.
So X squared plus Y squared equals 1. That, by the way,
That's generalized.
it is generalized. Is the equation of a circle.
Can you also do that?
I'm going to do that also. I'm going to do 2 ways. That's equation of a circle with a center at 0, 0. Ah, geez. And radius of 1. If you were to plot that in decimals, I know we haven't talked about equation of circles. You will do that in pre-calculus. But it's a very basic equation. X squared plus Y squared equals 1. Maybe you guys in geometry, I don't know. But that makes sense, right? Because X and Y are on the circle, right? Also, sine theta equals Y and cosine theta equals X. That's only for the unit circle, though. Please don't confuse that, because I had students pre-calculus many years ago that thought this worked for any type of trig situation. That's not true. This is only for the unit circle, because that's what the question is asking for. Remember, unit circle is raised to 1, right? Center 0, 0. So sine theta is Y, cosine's X. That should hopefully make sense. Adjacent over hypotenuse, your adjacent is X. Your hypotenuse is 1. Opposite over adjacent, sorry, opposite over hypotenuse. Your opposite's a vertical leg, that's Y. Hypotenuse is 1. It also, if it helps, cosine comes before sine in the alphabet, X comes before Y in the alphabet. That helped me remember in high school. I'm sure that helps you guys too. So, does that make sense? We're good? Okay. So that's how we could generalize it, okay? Now we're actually going to Well, were we gonna graph a cosine function? I think I have to look. Maybe not. Oh, no, we are. At the end, we're gonna graph a cosine function. Okay. Next up, what can a sine value tell you about a point on a circle? It gives you the y coordinates. The cosine value gives the x coordinate. But more specifically, this is only for a unit circle. This is only for a unit circle. So just a quick aside here. What if I had a circle that was like this? Okay, that's not a good looking circle. What if that were like 2? Or let's just call R in general. Okay. Okay, hope you guys can read that. And it's theta. Yikes. Theta's right there. My sine theta would be what? Y over what? Exactly. And my cosine theta would be what? X over R. Because over hypotenuse. So just so you know, the sine value involves Y, the cosine value involves X. It's exactly the Y and X coordinates if it's a unit circle. If it's not, then divide by R, because it's a ratio. I just want to make sure we're aware of that. For 748, if you know the sine of an angle in a unit circle, can you find its cosine? Yes. And that's because x squared plus y squared equals 1. So say, for example, I have sine 30 degrees equals 1/2. So you could do x squared Okay, so by the way, if you look this up, or if you punch in a calculator. Oh, we should know that. How would I know that using the 3690 ratio? How would I know that using the 3690 ratio? What would I?
Like the sides.
Yeah, 100%. If that's 2x, that's x, and that's x root 3. Okay, but here's a 3690 ratio. Sine, right? Is that opposite over hypotenuse? What's x over 2x would be 2? Wow, I know that. Okay, cool. So the question is asking, if you know the sine of an angle in a unit circle, can you find the cosine? Yes. How can you do it? You can use Pythagorean theorem.
So what even is like a unit circle?
A circle with the center of 1 and sorry, center 0, 0 raised to 1. So center 0, 0 raised to 1. If I were to solve this, what would 1/2 squared become? But what 1/2 times 1/2? 1/2 times 1/2? 1/4, right? You did 1/2, 1 plus 1/2. So you got multiply it. If you subtract 1/4, what do you get? What's 1 minus 1/4? 1 minus 1/4?
1 minus
3/4.
3/4. Think about if you're baking something, if you take a cup of something, you use a quarter cup, you have 3/4 cup left. If that helps. Anyway, and if you square root, what do you get? Root 3 over 2. Right, because you have to square both top and bottom separately. Right, when you square root a fraction, you got to square both top and bottom separately. So this means that cosine of 30 degrees is root 3 over 2. Clearly, you can use a unit circle or use a 3690 triangle. Just trying to show another relationship, that's all. That's what we're trying to do there. But if you know the sine, you could totally get the cosine afterwards. It's all good. Another way you could do it too, by the way, you can always just, if you know this, right? Can you just draw a right triangle and label the sides? So what would be the opposite side? No. If sine theta is 1/2, what would be my opposite side? How long would that be?
1/2.
1. What's my hypotenuse? 2,
2√1.
and that's √3. So I can find the cosine afterwards as well. So you could, that's another way you could do it. You could do it that way. So there's a few ways you could do it. So again, you could use x squared plus y squared equals 1. You could draw a triangle, use a 36 ratios if it's 30 degrees. So a lot of different ways you could do it. All right. So let me have you guys figure out 7/4. Do this in your with your partner or whoever you're sitting next to. So let's say the cosine of theta is 3/4. So find the exact course of point Q. So what are you going to do? So say I call this 4
Why
And
you
that-
calling it 4?
and that 3.
I thought it was 1. Like,
But
the
in this
unit.
case, it's not new.
I'm doing 3. Oh, are you thinking about the unit circle?
Yeah, shouldn't it be 1?
Actually, you are right. It's the unit circle. You are correct.
Dang.
You are correct. No, you're right. You're right. You got me there. Okay, so solve for y.
So, like,
No, I didn't see that.
Three
It
fourths
did say unit
squared.
circle.
Plus y squared.
Correct. So you can do 3/4
1.
squared plus y squared equals 1 squared. Correct.
Yeah.
So tell me what you get for y. And then we can do sine theta after that.
Oh, no.
Actually, should be, let's get an exact answer, actually. Not an approximation. Okay, so tell me what you guys get for y. Let me work it out.
And then
Do you have an answer for y squared?
like
What
the square root of
or give us a
0.-
fraction for y squared first.
I don't
Okay,
know.
9/16 is the left side. Move it over to the other side.
Wait, how do you get 9/16?
Okay, that's good though. Now you're on the right track.
Oh, I shouldn't just like actually put it into the calculator. Okay.
Okay, when you get 9/16 to the other side, you're doing 1 minus 9/16, right? How would I do that? How do I convert 1 to a fraction?
1/1.
Okay, good. Now make 16 the denominator. Good. 616, yes. So y squared will be 16/16,
Over 16 minus 9 over 16.
which becomes 7/16.
Square root.
So what's y gonna equal now?
Square root of 7/16.
Over 4.
What? Oh.
Because you gotta do both top bottom separately. So the exact coordinates are gonna be this: 3/4, comma, √7/4. So that's what the y. So does that make sense? So cosine theta was that. My bad. The hypotenuse had been 1. I made the hypotenuse 4. So
You're
we get
welcome.
1. 3/4 and 1. Thank you for catching that. That's y. And then I did diagonal theorem. 3/4 squared plus y squared equals 1 squared. Solve for y. Got √7/4. According to that. And what would be the sine theta? That's theta right there, the base angle. What would that be? Sine theta would be y/1. And what's my y value?
7
√7/4. Yep. So we're just connecting sine and cosine to the unit circle. That's what we're doing.
Quiz.
No, we got to do 750. I'm just gonna show you how the graph looks.
There's any room.
No, actually, this you guys could just watch. I'm just gonna just show you. And let me look at the homework's gonna be about for if it asks this for graph and cosine. It's homework number 19. It does talk about cosine a little bit, yeah, but that's more. Yeah, it does. Yeah. Okay. So let me show you the graph of cosine, guys, and we'll do the quiz, and then we're done. No, it's stuff from last week. I showed you the quiz already. Just the other version. Let's not worry about all this junk here. Let's go back to the unit circle again. You guys can just watch. Here we go. Algebra 2 trade honors. In the semester. Okay, here we go.
It's 9 to 12.
All right. What?
Yeah, what is that?
What's what?
You
Oh,
gonna
the
memorize that?
unit circle. No, not all of it.
You're gonna give that to us?
Okay, hold on, guys. Let's talk about this. Okay. $30 degrees, right? If you think about it, how long is the hypotenuse again for a unit circle?
One.
The hypotenuse or the radius, 1. Good. And this has to be 1/2, right?
1√3.
And that's √3/2.
Oh,
Okay. So, oh, that's because you take the shorter leg. You do √3 times the shorter leg. Because short leg is 1/2. Okay. Now, if you think about it, the x coordinate is cosine theta. Right? Because the x coordinate is going to be, sorry, cosine is adjacent for hypotenuse. The adjacent is always x. So at 0 degrees, I know it looks a little daunting, this unit circle, but at 0 degrees, what's my x coordinate here?
1.
So I'm going to put 1. No. Give me the x coordinate. And why are your shoes off?
They're always up.
I know. I heard that. Even Ms. Gomez saying like, why is it's like I don't know. Anyway, I guess so. Okay, it's 60 degrees. What's the x coordinate 60 degrees? So it's a little bit before 90. And at 90, the x coordinate is 0. Cosine graph. At 120, it's -1/2.
It's like a semicircle.
And at 180, it's 0.
The line.
If you continue graphing it all the way around,
That's like, isn't that what we just did with like the?
sine graph, yeah. That's a cosine graph.
What's the difference between that and the one that we did for the?
Great question.
The Ferris wheel problem.
Great question. So that's a cosine graph. That's it's still the same thing. It's shifted actually. It's shifted. So sine looked like this. That was at 360.
Starts at 0.
Correct.
Starts at 1.
Correct. Now the peak here happened at 90.
Same slope though.
Same curvature. Not slope, it's not a line.
Yeah.
So if you think about it, this x-intercept's at 0. Where's this x-intercept?
Well, there's a 90.
90.
90.
This peak is at 0. This peak is where? 90. The word cosine. Does anyone want to take a stab what co is short for from geometry? From angles. So you remember you guys talk about how angles are related in 90 degrees. When we have two angles up to 90, what are they called?
Oh,
Comp.
compound.
Competition.
Complimentary.
Thank you, Nathan.
Still on that name, bro.
Bro, failed geometry.
You wouldn't have been here for failed geometry. Or we just let you pass.
Damn.
Okay. So cosine is a complement of sine. So they're always going to add to 90 degrees, just so you know. So cosine and sine have that kind of relationship with each other. So you're going to see that shift in 90 degrees between them. All right, let's go ahead and start. What time? We got what time? 11:35? Yeah, perfect timing. We'll start the quiz and you guys can use the rest of the time. I don't think you need 15 minutes, probably 5 minutes if that. And you can start homework. You
And
can,
again, since I was not
do you want to give it a try? Do you feel you could do it? Give it a try. Bless you.
try.
All right. And then as I promised,
How about your calculator?
Sure.
I have an next one. As I promised, I'll put these ratios up. Hold on, let me get a white background. Hold on. Oh, perfect. Perfect. There we go. I'll try to write neatly, not like a doctor. So there we go.
My dad told me I have doctor handwriting. That's not a
Actually, my friends with doctors have pretty good handwriting.
definitely not a compliment.
All right, there we go. Yeah, leave each other on.
But like, I get to.
Maybe then
Something group like six.
And I gave you, actually, I gave what you need. But there, actually, it's better. No, I'm going direct.
That's what it is, really.
Today is Monday.